In this video, we're going to talk about what we do if we have more than two functions and we try to use the product rule. So, for example, let's say what you're trying to do is, so you try to take the derivative of f times g times h. So you have three functions. So if you have three functions, what we can do, we're going to separate them into two groups. So I'm going to consider the first function as the u, the g and h function as the v. So we can consider those two as two functions and then use the product rule as before. So what we do, so we take the derivative of the first function, multiply by the second one means a gh in this case, and then take the derivative of the second one is a gh, and multiply by the first function. So that's the multiply by the first function, the derivative. So that's the product rule, and then you can see that we have a product here again, so that means you have to use the product rule again. So that's what happened. So that means you're gonna get, so df over dx times gh plus, and if you use the product rule here, what happened is take the derivative of the first function, multiply by the second one, and then take the derivative of the second function, multiply by the first one, times f. Now what we do, we can distribute it and we can write it like this. So it is df over dx times gh, then dg over dx times hf, and then dh over dx times gf, and then you can see that gf. So you can see that we take the derivative only one function at a time, and also there's a nice cycle pattern. If you start with f and f, g and h, so we write them as a cycle like that. So what does that mean? For example, we can write the product rule for three functions like this. F g h prime is, take the derivative of the first function and look at the cycle and write the other two functions in the cycle. So in that order. So f g h. Now take the derivative of the second function g prime, and if you go to cycle is hf. That's the cycle. And then if you go to the last one, is h prime, and then fg. So that's the cycle pattern for three functions. So, and using the same cycle pattern, you can just write for any number of functions. And then one thing important is your derivative only applies to one function. That's the most important part. So derivative apply to only one function, only once, just once, and then you just multiply by the other two. So that means if you look at the four functions, what will happen? So let's say you have f, g, h, and k. So the prime is, again, if you look at the cycle, so it is f, g, h, and k. I mean, you don't have to, but it's gonna make a nice pattern. So what happens is you take the f prime and then g, h, k, and the g prime is k, h, k, f, and the h prime k, f, g, and then k prime f, g, h. So that is the formula you get for four functions. So formula for four functions. So let's look at two examples and see how we can use this idea. So let's look at an example. So we have find the following. So let's say the first one is we try to find the derivative of x minus 1, x minus 2, x minus 3. So that means if we use the 3 version, so we have three functions here. So what we're going to do is we take the derivative of the first function. So that functions are, so we have f, g and h, f, g, h. So what's the formula says? Find the derivative of the first one, multiply by the other two. Then find the derivative of the second one, multiply by the other two. And then find the derivative of the third one, multiply by the other two. So let's find the derivatives. So it is 1. So since the derivative is 1, you only get x minus 2 times x minus 3. Again, the derivative, this one is 1. So that means you're going to get x minus 1, x minus 3. Similarly, derivative of this one is also 1. So you get x minus 1, x minus 2. Now what we do, so we're done with the derivative. Just simplify the expression. So when you distribute, you get x squared minus 5x plus 6 from the first one. From the second one, you get x squared minus 4x plus 3. Next one, you get x squared minus 3x plus 2. So if you combine all the like terms, you get 3x squared minus 12x plus 11. So that is the final answer. So let's look at one more. So we have we need to find the derivative of t et sine t. So again, if we apply the result, we take the derivative of the first term, multiply by the other two, which is et sine t, plus find the derivative of the second one, multiply by the other two, t sine t, plus find the derivative of the last one, and then we have t et. Okay, so let's find the derivatives. T means it is 1, so you get et sine t from the first one, plus derivative of et is et again, so it's et t sine t, and the derivative of sine is cosine times t et. Now what we do the algebra part. So you can see that et is common to all of those terms. So that mostly happens when you have et functions. So it is et, and if you take that out as a factor, you're going to see sine t plus t sine t plus t cosine t. So that is the derivative you get. Now you can try these problems as practice problems, and again you can match the solution with the solution in the description. So as practice problems, try to find the derivative of the following functions, and you can see that there are more than one function here. So how we do it? So you can use the technique that you learned in the earlier section and see whether you can bracket it like properly, so then it's gonna make it easy, especially for the last two. And also for the last one, you have a different argument. You can also do this in a different way. You can first simplify this one and then use the formula for that one, and then match the two answers, and what do you get for those two answers. Okay, so you can try them and match the solution with the answers given in the description. Thank you.